Hello, hello! Let's talk about domain, range, and the end behavior of rational functions. All right, let's begin by looking at the parent graph and seeing what's happening there. For domain, what we do is we go from the smallest x to the largest x we have. That means first I start all the way to the left. All the way to the left, my curve here, it goes to infinity. Well, to negative infinity. And all the way to the right, I go to positive infinity. However, I run into a little bit of an issue. I have that vertical asymptote of x equals 0. We can't cross our asymptote. So, we got to skip over it. This is how we'll do it. We first go from negative infinity to 0. Then we stop. We create a union between the right side, where we start at 0 and end at positive infinity. So this is the left side of our graph, and this is the right side of our graph, with, of course, that little break in the middle. All right, let's take a look at the range. For the range, we're looking at our y's. What is the smallest y? Well, if I keep going downwards, I'm going to hit negative infinity. Great. Oh, that was a bad infinity. Let's try that again. That's a little better. And if we go all the way up, we're going to hit positive infinity. However, you may notice that we have a horizontal asymptote that gets in the way. So as we're going from the bottom to the top, we have to skip over our asymptote, which means we're going to write it in a similar way as our domain. We are going to skip over 0, and we are going to go from 0 to positive infinity. So in this case, that's our bottom. This is our top. So the bottom and top versus left and right. Okay. Let's take a look at the domain of and range of the other graphs that we worked on in the previous video. Okay, so domain for this graph. Okay, so going left, all the way to the left, we go to negative infinity. Great. I need to zoom in a little more. I can't write that tiny. Bloop. Okay, we go all the way to infinity. And then we run into that same issue. We have this vertical asymptote of x equals 0, so we cannot smoothly go from left to right. Once again, we have to skip over that 0. I write a U for union. I know, very creative. Good job, mathematicians. Very creative. U for union. And we go to positive infinity. Okay. Let's do the range. For the range, on the bottom, I can go all the way down to negative infinity. But when I'm rising from the bottom to the top, I run into that same obstacle of an asymptote. In this case, we have y equals negative 4. So our range begins at negative infinity, but we have to take a stop, a pause at negative 4. And then, after negative 4, we can continue on all the way to positive infinity. Let's try another one. Okay, domain. Okay, all the way to the left, we start at negative infinity. And we run into the obstacle of our vertical asymptote, which in this case is negative 3. However, we do have a union because we can start back at negative 3 and go all the way to positive infinity. All right, range. Once again, the lowest we have is negative infinity. And as we go from the bottom to the top, we run into that same issue. Once again, we have our asymptote. This time our asymptote was at 0. And then, after the asymptote at 0, we can continue on to positive infinity. Let's do this last one, and then we'll talk about end behavior. Okay, domain. We go from left to right. At the left, we start at negative infinity, but as we go to the right, we run into our vertical asymptote of negative 5. Are you noticing any pattern here? Or maybe any relationship between the asymptotes and the domain and range? I hope you are. Oh, I don't know why I wrote negative 5. That's a good question. Bad, Miss Gumin. All right, 5, and then we skip over 5 and go all the way to positive infinity. And then for our range, we start at the bottom, that's negative infinity, and as we go up to the top, we run into the horizontal asymptote of y equals 2, so we have to skip over that as well. So we go from negative infinity to 2. We have to skip over it, but we're saying, hey, there's a union between that and going from 2 to positive infinity. I hope you notice the relationship between the asymptotes, domain, and the range. Now let's talk about end behavior. Let's look at the original graph. I'm gonna copy paste this little section so I don't have to retype it. Write it with my handwriting. How about that? Smart. Smart. Good job, Ms. Gumin. Good job, self. Okay, so end behavior. As x approaches negative infinity, what happens to y? Well, let's see. As x goes to the left, y keeps approaching this horizontal asymptote. It keeps approaching 0. As x goes to positive infinity, so as we go to the right, our y's also get super close to 0. Let's look at the other ones and see if you notice a pattern here. As x approaches negative infinity, as we go to the left of our graph, our y's get very close to this horizontal asymptote, which is negative 4. Good. And as x approaches positive infinity, we're going to the right, and we're still approaching negative 4. Okay, let's see the next one. All right, as x approaches negative infinity, as we go to the left, once again, we're hitting that asymptote, 0. And as x goes to the right, once again, our graph is getting close to that asymptote, to 0. All right, last one. As x goes to the left, as it approaches negative infinity, our graph gets closer and closer to the asymptote, which is 2. And as x approaches positive infinity, as we go to the right, our graph, once again, is approaching 2. I hope that you can see all of these relationships. I did my best to color code them so you can see how the asymptotes relate to the domain, to the range, to the end behavior, and to the equation. Okay. If you have any questions about this, please feel free to ask myself or your teacher. Otherwise, have a wonderful rest of whatever day it is for you. Bye.